Me, myself, and I, that's all I got till the end of time.
Dance. Some people wish they could, some people just can, and there are those who train their entire lives to be the best. Today we're going to delve into the physics of dance. Specifically, we're going to see just how much physical power goes into this 4-minute routine. Okay, so what equations are we going to need to solve this problem? We're going to need the equations for power, work, and force. The first equation for power is work over time, or W over T. Second equation is for work, which is force times distance. And the last equation for force is the coefficient of gravity, which is negative 9.8 newtons per kilogram, times the mass. We're going to start by solving for force.
To solve this equation, let's just say the mass of the dancer is 50 kilograms. Okay, so let's just get into this. To solve this equation, we need to multiply the coefficient of gravity, negative 9.8 newtons per kilogram, times the mass of the dancer, which is 50 kilograms. And since we're multiplying kilograms by kilograms, we can cancel them out from the denominator. So now we just need to multiply the coefficient of gravity times the mass to get an absolute value of 490 newtons, which translates out to 490 newtons. Awesome, now that we got the force, let's solve for work. So we know the equation for work, and we know the force we used. And the distance that I danced from either side of the dance studio was about 10 meters. So we just need to multiply those 10 meters by the 490 newtons. A quick calculation later, and we get the answer of 4,900 Newton meters, which translates out to joules. Now that we've got our work, let's wrap this up and solve for power. So now that we know the work, all we need to do is convert the time from minutes into seconds. I danced for about 4 minutes, so that translates out to 240 seconds. And now we just do a quick division problem. So 4,900 joules divided by 240 seconds comes out to about 20.42 joules per second. But joules per second can be converted into watts. So our final answer is 20.42 watts of power went into that 4-minute routine. Now, a little more than 20 watts doesn't sound like much when you compare it to the watts in a light bulb, but it actually does take a lot of energy to do a dance like this. Most dance videos you'll see online are about 1.5 to 2 minutes. That's just because the dancer needs to be able to distribute that 20 watts over an entire song. And just so you can see where that 20 watts went, I'm going to let you finish my routine, and I hope you guys enjoy it.
We can last forever. Come on, baby, won't you hold on to me? 'Cause there's no one else like my daddy. I don't know much about algebra, but I know I'm dangerously in love with you. All the single ladies, put your freakum dress on. All the single ladies, and let me upgrade you. All the single ladies, I wanna be myself tonight. All the single ladies, now put your hands up. Let me upgrade you, Audemars Piguet. You switch your necktie to proper labels. Upgrade you, can I let me upgrade you. Let me upgrade you. Can you give me body? I wanna be myself tonight. Can you give me body? I wanna be myself tonight. Don't you see my body? I wanna let it out tonight. Wanna party? 'Cause I'm tryna make a from the. 'Cause if you like it, then you should've put a ring on it. If you like it, then you should've put a ring on it. Don't react, 'cause you see that he want it. 'Cause if you like it, you can watch me on your video phone.
Thanks for watching. This video was so much fun to make, and for my subscribers, if you want to see more dancing videos from me, you can leave your song suggestions in the comments below.
And if you want to watch the full dance, the link is at the top of the description box.